Welcome to the Track 7 Mass Effect track in the Romans conference room. We chose a room with some mood lighting for this particular talk. This is Hookin' Ain't Easy, Beef Injection with Man in the Middle, otherwise known as That Man in the Middle Talk with the disgusting title, with Steve Osepik and Ryan Lynn. Steve is a senior security research manager at Trustway Spider Lab. He holds 4 patents with a patent pending. He's done many things, but really, we all know him from Laser Cats. Ryan Lynn is a pen tester, author of the book Coding for Penetration Testers, and he's a contributor to a number of open source projects.
Thank you. So yeah, you all came out. I was noticing, we're sitting here, there's at least 98% men, and we realized that maybe we might have alienated a few people with the name of the talk. So, but I did want to tell you congratulations, because you've actually chosen a talk, and you're finishing strong, I got to tell you. You've actually chosen a talk that was denied by DEF CON. First time I've ever seen this happen. I think it was actually a little too edgy. The comment made was might offend sex workers. Now that, so that being said, I just wanted to say up front, I apologize. We're not talking about you. If there's anybody in that industry in the audience, I think there's something here for everybody. That being said, this guy voted yes, so I'm not sure what that means. It's kind of mixed signals. But so yeah, I'm Steve. This is Ryan. What we're going to talk about is really the combination. This kind of came around from doing pen tests, as a lot of this stuff does. The combination of not being able to use your microphone correctly. The combination of doing the penetration testing and trying to, we're always trying to find ways to hook into these machines, right? So get into a network, you've got a certain amount of access, you're trying to sort of take it to the next level. And we find ourselves in this situation a lot. There's a lot of old stuff in this presentation, actually. I've done several presentations on Man in the Middle, specifically art poisoning. And Ryan came to me and had a kind of an interesting idea that we could combine this with something called the BeEF framework. That's something we're going to talk about, allows you to really hook yourself into clients, hook into HTTP clients like web browsers, and actually start to perform actions on their behalf and actually go through them. So just to kind of set this up, it's your sort of traditional story. It's the the love story. A boy meets girl, tries to impress girl, hilarity ensues, and then of course a foreign exchange student comes around, sweeps her off her feet, and then you got the video montage. But right, boy becomes a man in the middle. Boy installs Backtrack 5. Boy follows girl into coffee shop, and of course uses Ettercap to inject traffic into the HTTP stream. So what we end up with is, it's kind of like our own version of the hotspot, but you just basically have a couple options there, and a very important question presented. And just like a regular hotspot, if you click the right button, and you get access to Facebook and the internet. So it works out really nice. It's actually a really good way to get a date, apparently. But how does this work, right? How do people do that? And that's going to be the first part of this talk. And by the way, I don't want to. Again, I'm all about not offending people. So we want to make sure that everybody is represented here. Okay. So the diagram. I've explained art poisoning a lot. It's like one of those things you have to, if you're going to do a talk and it's going to have art poisoning in it, you just have to explain it. So bear with me if you know what it is. It's motherhood and apple pie kind of thing. But if you don't know what it is, if you know what it is, I think it's going to be one of the more enjoyable discussions on what it is. Otherwise, listen up. It's really not that hard. So you've got these 3 machines. The top one is the router. Let's say this is the hotspot. Okay, the top one's the router. Then there's the, victim or whatever down here in the bottom left, the soon-to-be date. And on the bottom right of the screen, you see there's a good old PTJ trying to get a hookup. So we're just going to shorten these up. You have IP addresses and MAC addresses. Okay, so the MAC, the MACs, the MAC gateway, the MAC A and MAC B. Let's just make it simple on ourselves. Okay, all this is that ARP, for those of you who don't know, ARP is very simple. It's just a mapping between an IP address, which is layer 3, and a MAC address, which is on layer 2. The MAC address is burned into the factory. It's at the lowest layer of networking. That's kind of how things communicate. The IP address is assigned dynamically. So what it is it's kind of a lookup table. It says this IP is associated with this MAC. So right now, MAC A, this person here thinks that the gateway is at the MAC gateway, the MAC of the gateway, which makes sense. And of course, the ARP cache of the gateway is right. It says that IP address associated with MAC A. You can kind of see where this is going. So there's the Facebook. Then this guy gets involved. Now this is actually what's called, we took a little jump ahead. There's ARP reply poisoning, there's ARP request poisoning. This is ARP request poisoning. It's a little sneakier. You're actually asking a question. In this case, we're asking the victim here on the bottom left, we're asking them what's their IP, all right, what's their MAC address? Tell me, and by the way, my IP is the IP of the gateway and I'm at MAC B. So that's a little messed up. And basically I'm asking him a question, but I'm also saying, by the way, you send it to me, I'm the gateway. That actually works a lot. There are some OSs that don't like that. OpenBSD comes to mind. There's a few that this is old. Again, this is really old stuff. But generally speaking, this is pretty successful. That basically our PGJ guy gets mapped to the IP address of the gateway. So Facebook.com, if the machine's going to go to that site, it's going to go to PTJ. Now we do the same thing. We say, who has 10.1? Tell me, and by the way, .100, I'm at MAC B as well. So the ARP cache gets updated on the router, and the same thing happens there. So then we forward this stuff through, okay? But then what do you do after that? Well, this is where we run into a little bit of a snag, because there's a lot of stuff we can do. There's UNC path injection. There's a lot of stuff that we've already been doing with things like, I guess, Firesheep and stuff like that, depending on what you're using. EtterCap can do a lot of stuff. But a lot of times we find ourselves just sort of watching traffic. If it's in a pen test, if it's something else, you just end up like watching the packets literally go through you. But the thing is, it still works. It still works in over 90% of our pen tests. And it's kind of a problem because it's been overlooked. People don't really think of it as big of a problem as it probably is. There are security measures available. You don't see them very often. There's things like ARP poison detection and countermeasures. It's in that classification of problems where people think it's not something you can actually fix, or it's not worth fixing, or, oh yeah, of course, if you have access to the layer 2 network, then of course it's game over for everybody. But I don't think it should be that way. We think of it like the inevitable. So if you're sitting at the keyboard of the server and you have a password, well, of course, you're going to get access. But I wouldn't throw it in that same classification, honestly. And of course, we always win in the hotspot scenario because the girls need to get to Facebook, and they always click the yes button eventually. So that works out pretty nice. But in the real world, it really is, once you get access, once you're able to get access this way, it's a good way to pivot, right? So it's not just that basically you're doing the ARP poisoning and you have access to the machine now. Once you get access to the machine, you can then start targeting other things. It's also somewhat hard when it comes to forensics. There really isn't anything that generally, there's some of the older stuff like ARP Watch and stuff like that will do logging of ARP, but there just isn't a whole lot of data kept in this area. Like I said, we use it a lot in pen tests. It's great recon data. It's great to see where people are talking, what are the interesting machines, and as you've probably heard of the UNC injection before. I'm just going to go real quick through a couple tools that are sort of the bread and butter in this space. Again, for those of you who've been using these tools, you'll probably be very familiar with them. This one in particular, I imagine a lot of people have been using EtterCap. I've been using EtterCap since like 2001, I think. It's a really feature-rich man-in-the-middle framework. It was actually some new maintainers recently, which is great to see. There's something that's part of it's called EtterFilter, which allows you to take these, basically make a language and do replacement. You can say if you see X, change it to Y. It's very helpful. And honestly, when I first saw this program, I thought it was the most amazing thing I'd ever seen. We actually, I'm from the NAC space. I started a network access control company back in 2001, and we did ARP poisoning to actually protect devices in the network, and just kind of an interesting way of doing it. I was a big fan of these guys, Allure and Naga, who made this. In my mind, this is probably what these guys look like. I mean, I told you this was a little bit old, right? This is old technology, but I'm pretty sure that, this is pretty much what their life is like every day. SSL strip is another one. This is Moxie's tool. This was the thing where he's changing HTTPS to HTTP. He recommends ARP-Spoof. ARP-Spoof's the old Doug Song tool, so some of these might be ringing a bell. ARP-Spoof does the actual man in the middle, and then the SSL strip does the rest. ThickNet is my tool. Me and Wendell made this a couple years ago. ThickNet was another man in the middle tool that does Microsoft SQL and Oracle. It'll do like inject. It'll actually do interactive injections against that. So you just take over the session, and it's yours. Those of you who heard about it, we're in the licensing talks for the new line of men's body spray, which is kind of cool. So. The Cane Enable is another one, Windows-based tool, man in the middle. Lots of different types of hashes. This is the Windows, sort of the Windows side of this, right? If you're on the Windows platform, you probably use this one time or another. It is more like a point-and-click man in the middle. They've used it for demonstrations on things like taking over RDP sessions and stuff like that. So there's some pretty good stuff there. A screenshot of it. So that gets us up. Again, there's a lot of like explaining sort of the history of where we're at. But that gets us up to where we're at now, where we're just starting to sort of peel back what we can do with man in the middle. I mean, we've done RDP, we've done all the things we talked about, the UNC path injection, but it always feels like it's really, really hard. It feels like you got to write these custom filters. You have to jump through a lot of hoops to get it working. So one of the things we want to do is try to make this easier, and we wrote some tools to really streamline this process of getting in the way, and we targeted. I think what you'll see is probably the best attack vector out there. So I'll let Ryan talk about BeEF for a little while.
Thanks. So obviously browsers are very prominent in network pen tests. We see a lot of network traffic, and we see a lot of web traffic as part of it. So if there were one thing that we wanted to own, being able to own the web traffic would be a great place to start. So the other thing is so we can see the traffic, we can inject things into it. But one of the problems with the traditional man-in-the-middle tools is typically it's a one-to-one mapping. You can't dynamically pick what you want from moment to moment without stopping the tool, modifying code, restarting it. So for tools like Ettercap, you have to rebuild a filter, recompile it. For a lot of the other tools, you actually have to write custom plugins to do different things. So we wanted a way to be able to do this a little bit easier. And so obviously web browser is the best place to do it. And so being able to focus specifically on its own protocol is great. One of the things we want to be able to do is disrupt the users as little as possible. Because obviously if you just start injecting stuff into every single web page, you have a better chance of getting noticed. You have a better chance of actually causing the user who's browsing sites problems. And our goal is to keep the web browser up for as long as possible. If they click the close button, then we're done. So we want them to keep browsing websites, hopefully very long, interesting websites, so that we can keep our browser hooks alive for as long as possible. And so what we really wished is that there was something that would streamline this and make it easy and let us leverage all of these tools. So obviously BeEF is awesome. BeEF will allow us to hook different browsers. Basically what that means is by injecting a chunk of JavaScript code, we have the ability to create a beacon back and forth between them. So Browser Exploitation Framework is a Ruby application that has that JavaScript built in so that we can place that into a page and it'll create that beaconing. But also it allows us to have a modular framework where we can pick specific things out of that framework that we want executed in the context of the browser. So in short, BeEF allows an attacker to control browsers. We can do lots of different things. The attacker hooks the browser, and then it becomes what is referred to as a zombie, because it's sort of wandering around on its own aimlessly until we will shift it a little bit and point it in its own direction, and then it continues to amble on. So everything that BeEF interacts with as far as the browser itself is JavaScript based. So anything that can run JavaScript code, we have the ability to hook. It's also modular, so as we come up with new things we want to do, basically write some Ruby code, and it's easy to incorporate. In the past, we've done some other things, incorporating into Metasploit. So for instance, one of the things we have the ability to do is to pass the actual browser hidden iframes to Metasploit payloads. So we're going to talk a little bit about how to fingerprint browsers, and based off that fingerprinting information, we can target specific browsers, send them specific exploits that we think are going to have higher likelihood of being successful to minimize the chance that both the user will notice us and also that we'll do something bad enough to the browser that it'll crash and we won't really get a second shot at them. So there's also some cool stuff with cross-protocol exploits. One of the nice things about XML RPC and all of the AJAX stuff that's happening is there's a lot of things that respond to web requests, and not all of them are web browsers. So for instance, IRC will ignore part of the HTTP header. So there's actually IRC exploits that we can leverage through the browser to attack IRC servers, printers, all sorts of other stuff. So even if we can't get into a certain place on a network, if we can make sure that that browser is beaconing back to BeEF, we can launch those exploits internally. And one of the most important ones that's been added fairly recently is we actually have the ability to proxy through that browser and execute requests through that browser with the credentials built into it, cookies that it is currently using, and also the access that it has from its network vantage point. So we have the ability to have a lot more control. So obviously, surprise, nobody really wants to have BeEF injection occur to them. But what we really want to do is figure out how to entice a user into this JavaScript code. So traditionally, the way that this has worked is through cross-site scripting. Either through reflected, which requires a user to click on a link that has cross-site scripting code in it. And that's usually part of social engineering attacks, something like that. And the other one is phishing and actually creating a static malicious site that has the hook in it, and then figuring out how to get people to click it. So all of those are sort of problematic because it requires you to trick a user into doing something. So what we wanted to do was make it so that we didn't have to rely on the user being gullible. We wanted to just go ahead and take care of that for them so they didn't have to worry about it. So this is a screenshot of the BeEF console. As you can see over on the left, there are the various hosts that are hooked. And on the right is some basic general information about the browser itself. But one of the problems with BeEF is, again, you can't just stick it anywhere. You have to find a web page to put it. You have to figure out how to get in the middle of the traffic so that you can actually get the JavaScript code executing in the browser. And so finding vulnerable web pages on an internal is really sort of a pain. And also, you really want to sort of make this as optimized as possible. So being able to just go ahead and stick this into the web page form is really beneficial. Phishing, you send out enough phishing emails, you're probably going to get caught these days. Somebody's going to turn into the help desk, and then they're going to send out the broadcast email. If you get this link, don't click on it. So the other problem we have is that hooking browsers is typically transient because you can hook a single vulnerable page. And if that page isn't very interesting, somebody's going to click on something else, and then the hook goes away. So what we wanted to do with this is have the ability to constantly inject the BeEF hook into the pages. So as people are browsing to different sites, we're able to inject into those pages on a regular basis to keep them coming back to us over and over.
So that takes us to where we're at now. That actually makes for a really interesting Google Images search. So, but the thing is, we're talking about manhood and that whole theme and womanhood, if you will. And honestly, do you see anything for children here, right? EtherCap's awesome. Okay, like I said before, I'm a big fan. Still a big fan. They're developing it a lot, but the thing is, it's gotten to the point where we wanted something that was a little more purpose built for this specific problem domain. There's some unique issues with injecting web content. If you've used EtherFilter, you have this thing where you're basically saying replace X with Y. You have to say wait for this specific thing to come along, and then we're going to just replace it with this, which is useful in some cases. But when it comes to something like HTML and the DOM and how you have these variable length protocols, it's not as flexible. There's some other tricks that we'd like to do that we can't really do inside of an EtherFilter. And as who's written header filters in here? Has used header filters for this? Does anybody look at the accept encoding? If anybody knows what I'm talking about there, that accept nannerpuss is like the equivalent to accept encoding. The reason why we used to do that is, okay, so what would happen is somebody would request a site, somebody would request a page, and the browser would say, like if they're going out to Google, the browser would say, accept encoding, and one of the things would be gzip. Well, that's really bad for us in the middle, right? This is a very bad situation because what's happening is they're encoding it using gzip, and they're spreading it across multiple files, so it's not plain text anymore. If we're going to mess with it, if we're going to add stuff to it, we don't want it to be encoded. So with EtherCap, a lot of times what we would do is, because you had to be very explicit, you don't want to mess with the size of the protocol. It just so happened that the word accept nannerpuss lined up with accept encoding. And so we started doing what we called the nannerpuss, right? But the nannerpuss is getting a little bit old, man. You know, he's getting a little tired. And it limits what we can actually do. This is an example of an header filter, if you're going to use EtherCap, that use a lot. I mean, there's a few different variants of this, but that's ensuring that when the web browser asks for a page, it comes back and it says it comes back in plain text, so we can mess with it. ThickNet was another one I looked at. I thought, well, maybe I can just extend ThickNet to do this, but it's really made more for interactive session injection. It's more about database protocols. It's overkill, maybe, and it's in Perl, and I had Ruby people, crying at me about it. So I said, fine, I'll make you a tool, and it will be in Ruby, and let's call it Shank, and use it as a verb on people. So down at the bottom of the screen there, you see there's a really nice, very simple tool we're releasing at the talk, releasing today now, that is called Shank. You can use it for lots of other stuff. You don't have to use it for this BeEF injection stuff. You can actually use it to do any kind of man-in-the-middle stuff. It's using a number of things. What's kind of fun about it is it's kind of the art poisoner I've always wanted. ThickNet had something sort of like this in there as well. It's stateful. So for those of you who have used EtherCap before, one of the things you know about it is initially you turn it on. It says, who's there? Where's everybody at? And then it gets a list. It populates once of all the different IPs in the network, right? At least last time I looked at the code. So if somebody comes along later, right? So like you're in a hotspot or something, or you're in a very dynamic environment, which most networks are with people taking their laptops home and whatnot. It's going to miss that because the person came in since you've done the scan. The nice thing about Shank is it's stateful, so it will actually watch the network. And anytime somebody, not just by doing periodic scans, it actually looks for broadcasts. So somebody jumps on the network and does a gratuitous ART, or somebody sends any kind of ART broadcast at all, it gets listed here, and it will get poisoned as well. There's only a few external dependencies. The main one's packet foo, so if you're in Ruby land, you're very familiar with that. And it actually does something a little nicer. It uses the actual RFC-friendly way of changing the encoding, which is to say accept encoding identity. I know that's kind of weird. That's kind of a weird word to use there, but that is the RFC for saying, don't send me anything other than just the basic text, right? That's basically just asking for plain text. So no more nannerpuss. Someday I actually like to take a shot at gzip. It's not encrypted or anything. It's just encoding. It's just you got to gather them, all the different, all the packets together in that. And meanwhile, the client's waiting for you. You have to gather everything that's in that communication stream, un-gzip it, then send it to them, and then, and re-gzip it. You also have to start at that point, because if you're going to mess with it, you're going to change the way it looks completely. You're going to change the size of it. You're going to have to start managing sequence acknowledgement numbers like ThickNet does. So it's hard. But this works just as well. So the other nice thing about Shank is it is, in and of itself, it is a poisoner, but it's also a forwarder. So sort of like EtherCap does at layer 2. If you're familiar with like ARP spoof, you set up ARP spoof, everything's coming to you, but your machine will just drop it on the ground. If you don't have IP forwarding enabled in like an ARP spoof scenario, everything's just going to go into a black hole. Your system's going to say, this isn't for me. I don't know why you're sending this to me. Shank will do it itself. It has to do it itself because we're actually changing stuff. Do not have IP forwarding enabled when you use Shank, because that will actually double your packets. You just want to let Shank handle that. I'm going to gripe a little bit, but actually it's gotten a lot better since another guy on the team took a look at the code and made it a lot better. Ruby and man-in-the-middle performance. The thing about man-in-the-middle tools, I've written a few of them now, is that performance is always the big sticking point. If you're going to jump in the middle between multiple hosts and you're going to basically be their way of sending traffic, you need to think about performance, because if you start dropping a lot of packets, you start taking a long time, you start running like large regex queries on all these things, it's gonna take a while. So performance was actually kind of a pain here. For those of you who've messed around with like TCP dump and you like BPF filters, this is like BPF filter porn up here, basically. This is one. The first one is basically saying the get. It's like saying if get is in the request, then send it through. So we're actually looking at the application layer itself. The next one is saying HTTP. Is it an HTTP response? So what this does, the reason I would do this in BPF versus doing it in Ruby is you want to send Ruby or your whatever dynamic language you're using, you want to send that thing as little traffic as possible. You want to send it only the stuff that it cares about, because you're going to take a speed hit. So what this is doing is this is a BPF filter, so it's basically telling PCAP, the PCAP library, that is closely tied to the kernel. The kernel has like a BPF device. And it's doing filtering. So it's basically Berkeley packet filter. So it compiles this sort of like in a virtual machine kind of language, and then it will apply that to the filter, and that's all written in really, really tight C code. So if you can take the time to figure out the BPF filter, like in this case, I know it looks really ugly, but you can actually get a lot of performance gains out of it. So if anybody's interested in that, we can talk afterwards. I tell you all about. I won't go into it now. It's a little ugly, but it's like the colon 4 is basically like the range, and then the offset TCP 12. That's like the offset. So what we're doing, the top line. I'm sorry, I have to tell you. The top line. If you do TCP and then you see those brackets around it, that's actually interpreting the internal portion of that line, which I didn't know you could do this until I did it for this tool, as a number. So we're saying if where the TCP basically ends is equal to get, which is kind of cool. That's pretty fun. You have what the other thing it does is it does multiple PCAP sessions. Some people think, oh, I got to get it all in one filter. I got to do all this stuff in one line. No, you can open up multiple packet descriptors and do it just as well. And that's what we do. We let PCAP do the work. If you use packet parse too much, right, the machine's going to get really hot and burn your legs. Packet parse inside of packet foo is actually it's a funny story. We've actually submitted some optimizations to that project. In the process of doing this, we found some things that could be optimized a lot. But packet parse itself is still going to look at the whole packet and try to figure out what it is. It's pretty slow. So with that, so the BeEF integration side, Ryan will tell you how we got that working.
One of the other things added to BeEF recently is a REST API. So we can actually communicate with the BeEF server from outside of the traditional web console. One of the things we wanted to do was to only poison hosts that weren't already hooked. And by doing this, we can limit the number of JavaScript scripts that are running inside the browser. But also, whenever we start modifying traffic, you have a chance that something's going to look funny on the page. You know, we're sort of taking our best guess about where to stick this in. And obviously, if you put it in the wrong place, somebody is going to notice. So we want to limit the impact on the browser, period, whether it's the load from the JavaScript. And also, if somebody has 5 different pages open, really, we only need one to be able to do most of what we're doing. So the other thing is again, we talked about before, with traditional ways that you inject the BeEF hook, if somebody leaves the page, they're gone. So by constantly re-injecting them every time we notice them go away, that means that we get to keep them hooked long term. So the other thing is, BeEF has an auto-run functionality. Right now, you can pick a module, and hopefully it's the bestest module ever, because that's all you're going to run automatically. So if you're on a local network with lots and lots of people, that's not really practical, because you want to get as much information about these lots and lots of people as possible to figure out who you really want to target. You want to get to the stuff that is going to, have access to intranet sites, access to maybe email, or financial institutions, the people who have teller systems open or financial management stuff open. So those are the people you want to look at. And so we want to profile as many people as possible. So with auto-run, it allows us to basically query when new people get hooked and then run a bunch of modules against them in sequence. But since it's in Ruby, we also have the ability to query basic information through the BeEF REST interface about the browser so that we target specific things based off the specific browsers. For instance, Chrome will give away different pieces of information than Firefox will, and IE6 gives away different pieces of information than IE9. So we may want to specify the types of modules that we're running from one point to another. And the other thing is we don't want to wait. We know that these people may go away, so we want to figure out who we want to target as quickly as possible. And then that way, if we do find somebody interesting and they do go away for a period of time, like for lunch, we know when they show back up, they're not somebody that we want to look at again. And so basically, the more information we have, the more targeted attacks we can do. We're going to look at, in a couple minutes, being able to figure out what plugins are running. So for instance, if you see somebody's running an old Adobe, that's obviously something that's interesting to a pen tester. Dump results. One of the other scripts that we wrote was once we start running these scripts, part of the problem with BeEF is that as you run them, the command results are returned back into the BeEF console. So the results are part of each individual command module. So if you run 20 command modules, you have to go and click 20 times in multiple different places to see what happened. And since it is per browser, per module, that's a lot of clicking if you have a lot of stuff. So as we are injecting these, we're logging the auto run output, and we're going to log that to a file. And then dump results is going to query all of that information, go into the REST interface, pull all of that, and just dump it to the screen. So this part isn't very full featured yet because we're trying to get some feedback as to what people and how people might be interested in having this information displayed to them. But all of the framework is here, so if you want to display it in a certain way, it's easy to modify. So we're going to look some at demo now, and we're going to go through this as a sample. So for the demo, we want to start off with some basic information gathering to start off. We want to fingerprint plugins on the target hosts, gather as much browser information as we can. Also look at what they're looking at so we can get whatever the current page is that we've injected into. Do things like enable key logging. So for instance, if you have a single sign-on page and we're able to inject into that page, being able to capture all the keystrokes on the page would certainly be handy. And then also one of the things that we use a lot in pen testing is the HTTP capture module and the SMB capture module. And so by injecting a hidden iframe, we can capture the challenge credentials, which we can then turn into usable usernames and passwords to compromise hosts that we might not have had before. Then the other thing is to get persistence modules running so that we don't have to keep injecting people. We can do things like pop over tabs, pop under tabs, launch new windows, so that the page that we've injected stays there for as long as possible. So here's the environment we have. We have a domain controller, user, and our attacker all in a local network. And then we have sort of the production network over on the side. So what we're going to be doing is we're going to try to figure out how to get to that production network. Obviously, we don't have credentials to get to it, so we might not be able to get there. But luckily, the user does. So what we're going to look at is figuring out how to leverage that user in order to get ourselves access. So everybody, think positive thoughts. Okay, so what we have here is we have the latest Ubuntu. And what we're going to do first is we're going to set up our Metasploit listener. Because one of the things we want to do is is gather challenge credentials as we have users coming in, so that even if we don't get anything good, as the browser sees us as part of their local network, they'll transparently send us credentials, and we can work on those offline so that we can get access to more stuff. So the two modules we're going to load are the auxiliary server capture SMB module, and so we can just type in run here. The other one is the web one, so auxiliary server capture HTTP underscore NTLM. The underscore NTLM capture module, instead of capturing basic auth credentials, is going to give the web page an NTLM challenge response. So it will encourage the browser to transparently send us their Windows credentials.
It's important to note that the capturing the credentials is not required for this attack. This is something that we like to show because it's a nice added benefit, but credential capture is not required for the BeEF man-mill stuff.
Right, and the default ports are sort of weird for this module, so we go ahead and set them to port 80 and / so that it's a little bit more traditional. So with those running, let's go ahead and see if we can get to the site first. So let's find our Firefox. So we want to go to an intranet site. So intranet. So actually, that is left over from the last one. So let me fix this. Yay, demos. So turn off our proxy.
Don't worry, we have a video if things go completely sideways. And the resolution is kind of awesome. I like when the resolution blocks you from even clicking OK. That's always the best. I'm not sure what you're going to do there. There you go.
Let's try that. Okay, so let's try this again.
Yeah, there
Okay,
you go.
username and password. We're better now.
So this is us failing, right? We're not allowed to get in there.
Okay, so that sucks. So from now, we want to figure out how to get that access. So the first thing we're going to do is we're going to load up BeEF. As soon as we find our terminal window again. There we go. So to make sure our BeEF is in a pristine condition, we are going to go ahead and specify the -x flag, which will reset the database and make sure that everything is fresh. So we can see here a bunch of information about BeEF launching. We can see all of the different information about where to go to get to everything, the API key, which we're actually going to get automatically, and also the most important one is the proxy URI, which we're going to use here in a couple minutes. So the next thing we want to do is we want to start Shank. So let's see.
Yep, over on the left. There you go.
So to run Shank, the only options that we really require are the network we want to poison. So and so we have to do this as root, obviously, because we're going to be generating raw packets. And so we'll do this on the 192.168.50 network. From here, we'll see a couple of different things. One is the BeEF thread started, just as sort of a debug message to let us know that it's connected to BeEF. And we'll look at this again in a minute as we start to actually poison traffic. So other thing we want to do is run auto run, which this is going to be looking for new browsers. So this is talking back and forth with BeEF as well. And as it sees new browsers come in, it sends all of the commands to launch the different modules we want. So there's already one browser hooked that was one of our test systems. So we can see that it went ahead and launched those. So next, what we want to do is we want to go and look at our internal box. So here, this is one of our internal users. We want them to go and test the intranet site. So eventually somebody on the inside is going to go and visit their intranet site. We've left the inject pop-up box there just so that we can see it for demo purposes. But obviously, traditionally, we wouldn't want anything to pop up. So that's one of the first things that runs as we inject the host. Once you click OK, we can see that, oh my gosh, intranets. So here we have the user that is now hooked. When we look at the browser code, here is the script that we injected in. So there is the first part with the inject, and here is our BeEF hook URL. So this is actually generating the code that's calling back and creating the beacon. So from here, we can go back and we can look at BeEF. Obviously, the new modules for this browser started auto running, and we can see that that worked. We can also look back at the window for Shank, and we can see a couple of things. One is we've added a hooked browser. We also see each one of these poisons as ARP requests are seen, it goes around and sends out new poisons. Overrode encoding, obviously, again, this is all debug messages to let us know that everything's working. So if you're doing this on a large scale, this is stuff that you probably want to take out. And then finally, when we look into BeEF itself. Hello.
Oh, there it goes. Oh.
Sorry. So when we look back into BeEF itself.
There we go.
It will show us that both stuff was hooked and also that the different modules ran. So this doesn't actually tell us about what information it got. So the other thing that we want to look at is transparently, we didn't see any pop-ups for the user, but here is the user's credentials that were passed in. So demo 1 user from the spiders domain, we now have their challenge credentials, so we can do a number of different types of password attacks on this in order to get access to their machine. And again, this isn't part of the attack itself, but this is a sort of bonus side effect that we use a lot while pen testing. So now that we have the browser in BeEF, let's look at BeEF itself for just a second. So when we look at the BeEF control panel, the first thing we see is username and password, which is by default BeEF and BeEF. So if you're actually using this on a pen test, change the username and password. It's in the config file, and obviously you don't want people helping you on a pen test. That would be embarrassing. So we see here, this was the test one that we hooked, and this is the new one that we hooked, the Windows. So here we see Safari, unknown. We know a little bit about it. We know that it doesn't have Flash installed, all of this goodness. So basically this is the result of some of the information that we gathered. We know that it's on the intranet site, and we also know the cookies from that site. When we look at some of the commands that we ran, one of the interesting ones is the get system info module. So you can see here that it actually has module results history. So when we click on that, if we can actually get to it, which yay screen resolutions. So we can actually see that. But basically what it shows, and I'll show that in just a second. Yeah. No. Okay. Good point.
You'll shuffle.
So the bad part is once you start reducing resolution, the user interface is really problematic. So from
As long as you don't have a Cirrus Logic graphics card, you should be okay, though.
Yeah, we can probably just make it really small. Actually, I don't think that's going to make any difference. There you go. You see it over here a little bit. So now you can see from over here that some of the stuff, actually maybe you can see, maybe you can't. We know the number of cores on the system. We know how much free memory. We know about the interfaces, specific OS versions, all sorts of other good stuff. But the real cool part about this is when we right click on this guy, we can set use as proxy. So now we can set a local proxy through BeEF, and all of our outgoing requests will use their browser to issue the request. So since they already have authentication, that makes sense. It's something we might want to use. So let's come back in here and we'll edit our proxy preferences. And right now it's set at no proxy. Before, when it popped up, it let us know that our proxy was at localhost port 6789. So let's go there. And so next we want to refresh the page. And obviously this is left over, I think, again, from before. But anyway, so we see that their browser is getting injected again. We see the pop-up box that they would have seen. And also we see that, and this takes, all of the proxy activities take a little while to load. So we see that we can actually see the intranet site as them, where before we couldn't do the username and password. So again, the other piece to this was that all of these different modules that we ran against them, we had some problems because you have to click on each individual thing. If you have a really small screen, you can't see the text unless you zoom out and all of that. So we also wanted to create an easy way of being able to get to that information. So we come back to the auto run. And so as you can see, all of this ends up printing out to the screen. So one of the things that I do when I run auto run is I tee this into auto.out. So when we run it again, we see that there's, again, browsers there. So it'll go ahead and run these. So now that we have captured that output, basically this is a series of JSON hashes that we can then parse by our secondary script, and we'll print all this information out. So typically when you're clicking on the user interface in BeEF, this is all of the information that you have to know. So programmatically, it's sort of a pain going from one step to the next because you have to go back in, query all the browsers, figure out how all of this matches up. And there's two different pieces. There's the module and the command. So unless we log this out, it's kind of hard to get to from the BeEF API. So what we do at this point is we dump the results. And so here we can see all of the different things that the modules output. So we can see here is the information about the systems, the display that it was on, all of the display information, the Java versioning, all of this goodness. And then also stuff that you'll see in here is if there's a lot of different other modules that you've run that have done information gathering, all of this will be here. Again, this is sort of a template for what people might like to do with it. A lot of the time when I'm doing specific things, I will look for specific message types from specific modules and either eliminate them from the output because I don't care, I just wanted to know the module ran, or take something like this and bundle it up in a more manageable form. So that is sort of the core of the two pieces merged together.
Nice. So that worked. That's awesome. So more information. I mean, we've just got some links here. I wanted to save time for questions, but definitely check out beefproject.com. Also, we put a link up here for the RESTful API. We're going to have up on the GitHub site, on the Spire Labs GitHub site, we're going to be releasing the code for this either later tonight or tomorrow morning. We have some DVDs here for those of you stuck it out. Want to ask some good questions or funny questions or whatever you want to, we'll reward you. It's a DVD, but I promise you, and it has beef injection written on the front of it. But I promise it's safe. So EtherCap, of course, can't enable all that stuff. Come on up and get the CDs. This is our Twitter information and emails. If you want to talk to us about it more, we'd be glad to talk to you. Big thanks to other Spire Labs people. Mikkel Oru works on Spire Labs team as well. He's the BeEF project lead. Helped us out with a lot, with ideas and guidance and that kind of thing. It's great to have him aboard. And Mike Ryan, another guy on my team who took my Ruby code and what was to him just a complete mess and waste of time, made it look like something I couldn't even understand in 10 minutes, and really boosted my self-esteem there. So, any questions? Oh, well, thank you. Question was, art poisoning tool, you really sure you can't present at DEF CON? Why? Are you offering? Oh, I see. Just use it there, is what you're saying? Oh, yeah, we could present like on the Wi-Fi there, right? That's what you're saying. Okay. That's not a bad idea. Any other questions? All righty. I guess it's first come, first serve on the DVDs up here. If anybody wants some, come on up. Thanks a lot, guys.